Girls, what do you think about what we are doing in the lab?
I think making crystals is cool.
Yeah, Blanca, what do you think about it?
I think we should probably sign up for the Eurovision Crystallization contest.
Okay, so first we need the utensils.
Wait, no, first we have to put our security stuff, so let's change. Now we're ready, so keep going.
Okay, now I will show you the utensils we need. Okay, so first we will need a container. Next we will need a beaker, a thermometer, a hot plate, a rod, a pan, and now we will continue to this part. We will need a little fridge, a rack with some test tubes in it, and food coloring.
And now what? The crystal suits just appeared.
No, are you crazy?
Now we need the necessary materials. First, we need water. We need monoamonic phosphate. And we also need sodium silicate. We need foil. And we need copper sulfate. And nickel nitrate.
And for what do we need those if we are going to use them for the crystals?
We need them for the chemical forest. Wait, I saw you. First, we grab the test tube.
And now we have to put the dissolution of water and sodium silicate.
In the test tube, we put the salts. In this case, we are using the copper salt.
Look what happens. This is called osmosis.
And that's it. So cool.
Now we are going to crystallize. And how do we do it?
To be able to crystallize, we need the necessary measurements of
Water, we need 500 milliliters.
And 300 grams of ATP, monoamonic phosphate.
Now we put the dissolution in the pen.
And liter by liter, we have to put the ATP in.
While you do that, we control the temperature until it reaches 80
We
degrees.
can put food coloring to make the crystal prettier and more different.
Now we have to cut like this the foil.
We put into the dissolution around 15 minutes.
When the time's up, we turn off the hot plate and take out the foil.
Now we have to take the container and put the dissolution into it.
Then we put the container in the fridge.
And now we let it go.
Finally, we have to wait a few days. Back to the lab.
Here we have our fridge.
Whoa, look how it grew. And that's it. Look how cool it looks. Now that the crystals are made, we will show you how our project finally turns out.
Importance of raising awareness in society about the impact that pollution, which we call crystalmination, has on nature, which we call crystality.
This is our crystallization project, and we are Blanca.
Martina and Luján, and we are from ES Antonio Machado High School.
try it.
Be patient
And have fun.
We are a group of students called Baking Crystals, and this is our project of the fascinating growth of crystals based on the kitchen.
We were inspired by the incredible beauty of the pulpigeo in Almeria, in Spain, and we wanted to grow our own crystals in the lab. Let's start!
Red cabbage broth is a natural pH indicator. When combined with ADP, we can see that it turns fuchsia because ADP is an acid substance. Later, when sodium bicarbonate is added to the solution, an effervescent neutralization reaction begins, realizing CO2. The change in pH prevents crystallization. We mix potassium iodide and lead nitrate. We see that a golden yellow substance forms, but due to the speed of the reaction, crystals have not formed. After heating it for a few minutes and let it cool slowly, we begin to see the formation of crystals. These crystals crystallize in the hexagonal system with 6 symmetrical sides. They are small, golden colored flakes.
We were looking for a visual element for our model and made a chocolate egg with a mold. The texture and shine of chocolate depend on how its particles are organized. To achieve the best form of chocolate crystallization, we use tempering, which involves carefully heating and cooling the chocolate. Without tempering, the chocolate can be soft, sandy, or have spots.